children. All right. Okay. So the whole thing with 7.3 is getting each side of the equation to a single base and that they are the same base on both sides. Okay, you guys know what I mean by base? I'm talking about powers. We'll go back to the grade 9 stuff. Little numbers, the exponent. Big numbers, the base. Okay, so 27, write it as a base 3 number. 3 to the exponent what equals 27? 3. If you can do that, you can do this lesson.
Do they get bigger?
Do they get bigger? Yeah.
See.
All right. 9 squared. We're going to write that as a base 3 number.
3 to the exponent 4?
3 to the exponent 4. I'd probably break it down like that first, if that helps your brain. So I took the 9 and wrote it as a base 3 number. And then that is law number 4 back there from grade 9. This is very handy for this lesson, law number 4. When you have a power inside and one outside, you multiply them. Okay. Now, this is no longer grade 9. When did we do rational exponents? Was that last year or grade 10?
Grade 11.
I feel like it might have been grade 10. Yeah, like, okay, so what does an exponent of 1/3 mean? Cube root and an exponent of 1 on the 27. So the numerator tells you your exponent and the denominator tells you what kind of root you've got going on there. That's just a review. Do not put it as a radical because that's not going to be helpful. Okay? So you guys told me that 27 was 3 to the exponent 3. So I'm going to go 3 to the exponent 3 to the exponent 1/3. Then I'm going to have 81. And that's going to be to the exponent 2/3. Do you see what I did there? I changed that radical into a rational exponent. Everybody good with that? But now I got to change that 81 to a base 3 number. Anybody have an idea of what it is? 4. Okay, now we got to keep simplifying. This one's going to be 3 to the exponent 1 times 3 to the exponent 8/3. Same bases. What do I do to the exponents? Law number 2 at the back of the room, we're going to add them. Okay, law number 2, we're going to add them. They have the same bases. We're going to add them. So that 1 is going to turn to a 3/3. It's going to go back to a 3/3. 8 plus 3 is 11. So that one's definitely a little bit more complicated, but not out of your skill set. I would say you should probably know base 1, 2, 3, 4, 5s to at least exponent 4s. Yeah.
How'd you go from like the 3 power 4 down to the next one?
This would be 4/1. So 4 times 2 and 1 times 3 gives me the 8/3.
That's a 3.
Yeah, sorry. It's not an 8/8. It's an 8/3. What? You just being kind to me? Logan, so the next step of this is you're going to have to write all this down in an email to me.
Oh, wait, all like a big collage or like individually?
Yeah.
Individually?
No, in groups of 5. Groups of 5. You send me an email. After you've completed 5 acts of kindness, you send me an email. And there are specific details you have to give me. If you do not give me these details, you do not get your coupon.
What details do you need?
Read your sheet.
That's not it. Just use the kind sheet your heart on.
All right. Okay.
He told him to shut up, take one away.
This This is not a leaderboard. Like, you guys, like, can you just...
It's a bad idea.
This was a bad idea. All right. Please do not make me regret this. All right. We are going to solve each equation. We're going to solve for the variable in these exponential equations. So the whole goal of this is, if you can, well, in this lesson, you 100% can, get them both to the same base numbers, and then you're going to set the exponents equal to each other. But it has to be a singular base on each side. Does that make sense to everybody? Like one base, one exponent, one base, one exponent. So let's start with something easy. This one's a base 4. Can 64 be written as a base 4? Yeah? Okay, so if we don't know that, we're going to start 4 to the exponent 1 is 4. 4 to the exponent 2 is 16. 4 to the exponent 3 is 64. I could have went base 2 numbers as well. If you wanted to do that, that would work. So we have 4 to the exponent x plus 2 equals 4 to the exponent 3 to the exponent x. All I did was I replaced the 64 as the power. Okay, so once they have the same bases, you can lose the bases. You don't cancel them out. If you cancel them out, that's bad, because we're not really canceling them out. We're just actually looking at the exponents together. So our next line is going to be this. You do not cancel them out. You do not draw a line through them. Do not do that. You just drop the exponent down and they become the equation. Okay, so I'm going to have 2 equals 2x. So x is equal to 1.
4 equals 4.
4 equals 4?
Something like that.
Yeah, 4 equals 4. Yeah. And that would make sense, because if we drop a 1 in here, that would be 4 to the exponent 3, 64 to the exponent 1. We'd have 4 to the exponent 3 equals 64 to the exponent 1. Those two things are equivalent. All right.
So do you want us to check our solution every?
No, you do not have to check your solution. Is checking your solution handy? See if you got it right, for sure, but it's not required for points. What? Nope. Nope, you're solving for x. You've completed it, you solve for x. You might want to check. You might want to check if you got the right answer. If I substitute x back in, will it give me left-hand side equaling the right-hand side? Okay, let's do the next one. Can 8 be written as a base 2 number, or base 4 number? So guess where we're going? Base 2s. Because 8 can be written as a base 2 number, so can 4. So 4 gets replaced by 2 to the exponent 2 to the 2x. 8 is 2 to the exponent 3 to the 2x minus 3. Is everybody okay with that?
Yeah.
And you're making the decisions based on what is the common base between them. And this trips people up because they're like 4 and 8. Those are common bases. It's going to be easy. And it's 4 to the exponent 2, but that's 16. Easy place to make a mistake. And super easy place to forget that you're distributing. Those of you that like, it's not because we're not smart, it's just because we get over-mathed, I think sometimes, or we're trying to rush. Those are the two things, like you're fatigued, you've got math fatigue, or you're trying to rush to get it done. I'm guilty of both of those things. Ooh, I used a decimal there. Feels wrong. Feels wrong. This isn't like, it's not super hard, but you do need to know stuff about your, like, base 2, base 3, base 4, and base 5. Like, I'd say up to exponent 4. And I think you probably all could do that without a calculator. The goal is to do this without a calculator. Will you have a calculator on your quiz on Friday? Absolutely you will. But you should be able to do most of the exponent, like, unit without your calculator. Okay, let's do the one right below it, since we're already here. I have a green pen and I don't know where it got to. Oh, there it is. All right, 9 and 27, what's a common base? 3. I was just gonna write 27 again. So again, we're just dropping those exponents down. We're not canceling out the bases. That's bad, oh bad, that's bad math. We're just dropping the exponents down because now we can set those exponents equal to each other. You guys had a question like this on a really early problem set. Maybe grade 11. Maybe I'm just...
Yeah, grade 11, the one that like everybody did.
I'm teaching grade 11 next semester.
How do you remember that?
Because what do I do every year? It's like, it's pre-cal all the time. Sometimes I get grade 9 to go with it. Sometimes I get grade 10 to go with it. Sometimes I get an essentials, either 10 or 12. Do you know I've never taught the grade 11 essentials credit? Never taught that course.
Why?
I don't know. I do the 10. Yep.
How many years have you taught?
That's a good question. In January, it'll be number 20, it'll be 23. 23, yeah.
Miss Galligan, you're an awesome teacher.
Yeah, see, okay, this. Hey, Steve, let's not investigate that.
He has a negative thing now.
Could you imagine if you guys were nice to each other all the time?
No, that's never happened.
Okay, all right. Okay, you guys do this one. You guys do this one, and I will catch up to you. While I regret my life choices. Is that the lesson?
Yep.
Sweet. What the heck?
Thank you. What?
Wow, Steve.
See, now he has a negative 2. He has no coupon. Take away one.
Shut up, you.
Take something from him too. Okay, say no.
Oh my God, I made a terrible mistake.
Not a mistake.
I feel, Tristan, I feel like none of this is genuine kindness.
Well, none of this is gonna actually count.
None of this is gonna count. What happens in our classroom doesn't count?
No.
I love it. That's perfect. That's a great rule.
No.
That's a great rule you just imposed. You guys are awesome.
No. Yeah, that should be a part. Logan, we're in the classroom.
Okay, did you guys get it done? Are you smart?
Logan let me rent his Lamborghini for a bit.
Did he? That's awful nice of him.
He gave me $200,000 the other day.
Yeah.
And the next masterpiece.
X equals 3, did everybody get that?
Yeah.
Math is good? And so that's it, that's 7.3. Like, isn't this a nice breath of fresh air? Like, it's math we can do, there's like a real answer that everybody gets.
You can actually get an answer without guessing.
You never